This tutorial will show how to include p-delta effects in a SAP 2000 analysis. There are two primary ways to include p-delta. One is to create a static nonlinear analysis case for each load combination that includes p-delta. This is the most accurate, but is limited to static analyses only. The second is to create a so-called initial p-delta analysis case, using anticipated gravity loads, and then using this modified stiffness matrix for all the other analysis cases, including modal, response spectrum, and time history cases. We will show both techniques. For our model, we will use a single column object. We start by applying a dead load of 100 kips at the top. We will apply a lateral load of 10 kips, also at the top. For the first approach, we define a new analysis case to represent the dead plus lateral load combination. This will be a static load, but nonlinear, so that we may include p-delta. For this case, we will combine the dead and lateral loads together with factors of 1. Although any multipliers may be used to match the codes or other requirements. Next, we go to the nonlinear parameters and click the Modify button. Here is where we can request that p-delta be included. Even though p-delta is a nonlinear effect, it may be utilized in all three levels of the program: Basic, Plus, and Advanced. We are now ready to run the analysis. We will open a second window so that we may compare results side by side. First, we display the results of the lateral analysis, which does not include any p-delta effects. The lateral displacement is 0.71 inches. Next, we will display the displacements due to the nonlinear static case, which includes p-delta. Here, the lateral displacement is almost 0.77 inches, noticeably larger due to the softening effects of the compression dead load. We will also display the moments due to each case. Here again, the moment is noticeably larger in the nonlinear p-delta case. Next, we will unlock the model to illustrate the second approach to including p-delta. We will define a new analysis case to represent the initial p-delta. This case may then be used to modify the stiffness of other cases. This case will again be static and nonlinear, and should include an appropriate gravity load, in this case the dead load with a multiplier of 1. Again, in the nonlinear parameters area, we set the p-delta option on. We will leave the solution controls set to their defaults. Next, we create another analysis case for the dead plus lateral load combination. This time, the combination will be linearly static, but we'll use the stiffness at the end of the p-delta analysis case. Again, the case will be dead plus lateral with multipliers of 1. We are ready to run the analysis. This time, we will display the nonlinear static analysis case in the left window. And the linear static case with the initial p-delta in the right window. Note that the displacements are nearly identical. A comparison of moments shows that they are also very similar for the two different p-delta techniques. The inaccuracies in the initial p-delta approach stem from the fact that the loads or load factors used in the various combinations may differ from the loads used when modifying the stiffness in the p-delta case. However, the advantage with the initial p-delta approach is that you do not need to perform a nonlinear analysis for each combination, and that it can be used in a dynamic analysis. We will illustrate that now with a modal analysis. Our default modal analysis case uses 0 initial conditions. And requests one mode, and we will leave it as is. However, we will add another modal case, which we will call PD modal, in which we will use the stiffness from our initial p-delta case. After running the analysis, we will switch the orientation of the windows. And then display the unmodified modal analysis in the top window and the p-delta modal case in the bottom. Note that the period of the first mode with the p-delta included has lengthened due to the compression softening. Again, running each load combination as a static nonlinear analysis will give the most accurate p-delta analysis results. However, for most buildings, setting up a single initial p-delta nonlinear case and then using the modified stiffness from this case in each of the other analyses, including dynamic cases, will give appropriate results.